Lesson 8.3 is on multiplying binomials. So a binomial is where we have two terms. When we're multiplying binomials, what we're going to be talking about is multiplying a binomial by a binomial. In other words, if we look at problem 1, this is what we're looking at. So 2x plus 4 is a binomial. It's being multiplied by 3x minus 7, which is another binomial. Before we work this out, I want to show that this does work. I want to prove that this works using just numbers. So let's say, for example, I have 10 times 15. 10 times 15 is equal to 150. You might say, well, what does that have to do with multiplying binomials? Well, what we're going to do is we're going to break these numbers down. So 10, I'm going to break this down as 4 plus 6. 15, I'll break down as 8 plus 7. Okay, you can pick different numbers if you want, as long as the numbers in the first binomial add up to 10 and the numbers in the second binomial add up to 15. And then what I'm going to do, I'm going to prove to you what the book's doing actually works. So what we can do, one way of thinking about this, if you have a binomial times a binomial, is you can distribute, in this case, the 4 to both terms in the second set of parentheses. So we can do 4 times 8 plus 4 times 7. And then we can also distribute the 6 to both terms in the second set of parentheses. So that would be 6 times 8 plus 6 times 7. So if we work this out, 4 times 8 is 32. 4 times 7 is 28. 6 times 8 is 48. 6 times 7 is 42. And then if we start adding these together, they're all being added, so we can add in whatever order we want to. 32 plus 28 adds up to 60. 48 plus 42 adds up to 90. And 60 plus 90 is 150. And you might think that was a very complicated way to work that out when we could have just done 10 times 15 to begin with. And I'll agree, I would never work the problem out this way, but I want to prove to you that it works, that if we do a binomial times a binomial, it's kind of like distributing both of those into the second set of parentheses, is one way of thinking about it. So if you look at problem 1, that's what they're doing, and they've got these in red and blue so we can see them a little bit better. So if we're working this out, first thing would be that we can distribute the 2x to both of these, and you can see that's what they did here. Now they put it still all in parentheses, which is fine if you want, I guess. And then they distributed the 4 to both of these. So they worked through that. What happened here is these were like terms that we could combine together, and so that's how they ended up with this answer. Okay, and again, not going through all the details there because we're going to look at another problem very similar. So if you look at the got it 1, they want a simpler form of this. So I'm going to distribute the x to both of these. And then you can either add the opposite here or you can circle that as a -6, but we need to see that as a -6. So just make sure you don't lose that sign. Okay, and then we're multiplying. So remember, we're multiplying here. We've got x times 4x. So we know we're going to have a 4, and then x times x is x squared. X times 3 is the same as 3x. And this would be minus 24x and minus 18. And then at this point, we've got like terms in the middle that we can combine. And that would be minus 21x. And so this would be our final answer for that problem. A way of checking it, I guess, one way you could do this is you could rearrange these this way. And you could work that out. So 4x squared minus 24x plus 3x minus 18, and then you get the same thing. If you look at problem 2, they're talking about how we could use a table to help us organize our work. If you want to use a table, that's fine, go for it. That's just not how I learned how to do these problems, but basically it's kind of like a multiplication chart in a way. So they just put each term, and you may want to add the opposite like the book did over here when you're thinking of what goes where, but it's x times 4x is how they got the 4x squared, and then x times negative 5 is negative 5x. Negative 3, sorry about that, negative 3 times 4x is negative 12x, and then negative 3 times negative 5 would be a positive 15. And then they're just taking these terms, then these products, they wrote them out horizontally, and then the middle terms they combined together. So like I said, if you want to do it that way, that's fine. Otherwise you can just think of it as distributing like we did previously. This next part goes actually more like what I was working the problems out earlier. This is how I learned how to work these problems out. And so it's really is just like distributing, but they came up with an acronym that you can think of to multiply a binomial times a binomial. So if you think about this, we have 2x times x is what we did first when we distributed. Those are both the first terms in the binomials. And then second, we multiplied the 2x by the 3. Those are the outer terms in the binomials. And then we started distributing the 2, so 2 times x. Those were the inner terms in the binomials, and then 2 times 3, which are the last terms of the binomials. So first, outer, inner, last. Acronym is FOIL. So this is, some people call the FOIL method. Okay, if you want to call it the FOIL method, that's fine. Again, it's basically distributing, but that's how I learned it also, was the FOIL method. So there you go. So if you look at problem 3, they used that FOIL method and distributed that. Most of the time what's going to happen when you work these problems out is those middle terms, the outer and inner terms, usually tend to be like terms that you can combine together. So in this case, that would be negative 1x or just negative x like the book had. So we're going to look at the Got It 3 part C just for something a little different. Well, let's go ahead and look at B first, I guess. Okay, so on part B, we're going to multiply our first term, so n times 4n, and then n times negative 7. And this is something that you may consider doing, circling terms if they have a negative or subtraction sign next to them. Negative 6 times 4n, and then minus 6 times negative 7. So n times 4n would be 4n squared. We've got plus negative 7n minus 24n, and then plus 42. Whoops. This was minus 24n. Sorry about that. And then we can combine these middle terms together. Altogether, that would be a negative 31n. So 4n squared minus 31n plus 42. Okay, and then part C I mentioned we were going to look at just as something a little different. What's different on these is we have already a squared term in our first binomial, so this is going to work out just a little bit different. So 2p squared times 2p plus 2p squared times negative 5 plus 3 times 2p plus 3 times negative 5. 2 times 2 is 4, and then p squared times p would be p cubed. And then this would be a minus 10p squared plus 6p minus 15. In this case, a little different. We actually don't have any like terms that can be combined, so this would be our final answer. Problem 4, we have a cylinder. They're giving us the dimensions there, and the question is which polynomial in standard form best describes the total surface area of the cylinder. So surface area of a cylinder, here's our formula for that. We did that in 7th grade with this formula. 2 pi r squared, that's the two circles, area of the two circles, and then the 2 pi r h is the part around the outside, kind of the curved part on the cylinder, which actually unfolds as a rectangle. So anyway, if you look at the picture, you can see the radius is x plus 1, so anywhere there was an r in the formula, they put x plus 1, and then the height was x plus 4. So that's just substituting into the equation. In this first part, x plus 1 squared just means x plus 1 times x plus 1, so they rewrote that. And then this part, then they went ahead and FOILed this out, if you want to say it. X times x is x squared, plus 1x, plus 1x, plus 1. And then over here, same thing. X times x is x squared, x times 4 is 4x, plus 1x, plus 4. Then they combine the middle terms together. 1x plus 1x is 2x over here. 4x plus 1x is 5x. And then we actually still have something to distribute. What the book noted here is that both of these have a 2 pi to distribute to them, so they just combined everything together and then distributed the 2 pi. Actually, they did that at the end after they combined like terms, so that's fine. Everything's being multiplied by 2 pi, so they combine their x squared terms, which was 2x squared plus 7x plus 5, and then they distributed the 2 pi to all of those. And then you can see that matches up with answer choice C. The got it number 4, it's basically the same idea, just they have a different radius and height, so we're not going to work that out. That's almost the same as what we just did there. One thing that they mention at the bottom of the page here is that the FOIL method works when we multiply two binomials, but not when we multiply a trinomial and a binomial. So in that case, different options. The book mentions you can use a vertical method. You can also just work it out horizontally, distributing. So here's an example of that, multiplying a trinomial and a binomial. So the book just lines this up almost like a multiplication problem. They put the binomial on the bottom, kind of like when you do a multiplication problem, you put the number with less place value digits on the bottom. Usually seems to look more correct for whatever reason. And then they just start multiplying. So they said, let's multiply -7 by everything in the numerator, which is really like distributing the -7. And then they said, let's multiply the 2x by everything on the top. Notice when they started multiplying the 2x by everything, we don't really add like a 0, a place value 0, but if you'll notice there is a blank spot here because 2x times 5, or 2x times -5 is -10x. So in order to get our like terms so we can combine those easier, it makes it easier if we just line up our like terms as we multiply. So when you work that out, then this is how this one works out. Just to show you another option for that, we could actually take that and we can rearrange it, is what I would do if I wasn't doing it the way the book did. And if we're multiplying, we can use the commutative property, change the order. I would just write it like this, have the binomial times the trinomial, and then we could just start distributing. So we can distribute the 2x. Make sure we think of this as a -5. And then we can distribute, this would be like distributing a -7. All right, so 2x times 3x squared would be 6x cubed. And then we've got plus 2x squared minus 10x minus 21x squared minus 7x and plus 35. And if you notice, I just distributed everything. I didn't really worry about what like terms I did or didn't have. If you wanted to, you could write those underneath, kind of like they did on the other problem. But I'm just going to look for like terms now. So 6x cubed, that's the only cubed term that we have. And then this would be minus 19x squared minus 17x and plus 35. Okay, so you can notice that's the same answer that the book had, just another option for you on how you can work that out. And again, that's kind of how I learned more how to do these problems, so that's what I'm going to show more often when I'm working these out, but that's personal preference there. So if you look at the Got It 5 Part A, again, whichever way you want to work this out, I'm going to work it out just by rearranging. I'm going to do a binomial times a trinomial. So feel free to pause here if you're watching this video. Go ahead and work it out and then see if this matches up. So we'll distribute the x. And then we'll distribute the -3. All right, so first part here we'd have 2x cubed minus 3x squared plus 1x minus 6x squared. This would be plus 9x minus 3. We'll look for like terms. We've only got one x cubed term. Make sure you include the signs when you're looking at these. X squared, we've got -9x squared. And then we've got plus 10x. and minus 3. And again, if you did it the way the book did, you should come up with the same answer. So we'll look at the lesson check. We'll just look at a couple more problems here, starting with number 1, just to practice again a binomial times a binomial. So we're going to distribute the x to both of these. One thing I didn't really talk much about, but you might notice when I am doing this, I'm drawing these arcs. And I know for a video that helps you visualize, but just in general, it's a good idea drawing these arcs to make sure we're multiplying to each term. Sometimes people do these and they forget. For example, they forget to multiply the 3 times 6. They just put a 6 instead of 3 times 6. So drawing those arcs just helps remind us we need to multiply to everything in each binomial. So we've got x squared plus 6x plus 3x plus 18. There's no subtraction signs here. That makes things a little bit easier to work with. Middle terms we can combine, so we've got x squared plus 9x plus 18. And that would be our answer for number 1. And then just to practice one more with a binomial times a trinomial, let's look at number 3. Okay, so number 3, they've already got it set up as a binomial times a trinomial, so I'm just going to start working this out. So we'll distribute the x. And then we'll distribute the 2. So we got x cubed plus 3x squared. This would be minus 4x plus 2x squared plus 6x minus 8. And then we'll combine like terms, so x cubed plus 5x squared plus 2x and minus 8. Just to mention, we're not going to work it out, but number 4, they talk about a rectangle. They tell us the length and the width, and they ask for the area. Area of a rectangle we know is length times width, so that would just be multiplying those out, foiling those, or distributing those, however you want to think of that. So this gives you an idea of how to multiply binomials. Have a good day.